Okay, so today we are going to look at the third method of solving systems of equations. We're going to solve them by elimination, which personally is my favorite. So the way we're going to solve this, you're going to make sure both your equations are lined up. And when I say lined up, I mean like if you have 2x plus 3y equals 7, make sure your other one is like x minus y equals 6. Your y's are with each other, your x's, and your constants. You're going to multiply one or both or none of your equations so that one of your variables has the same coefficients but opposite signs. And we'll go through that too. Then once that happens, you're going to add your equations straight down so that the one that has the same coefficient and opposite signs will cancel out. You're going to solve for your variable that's remaining to get your answer and then plug that into one of the original equations to get your other variable. That part's the same as substitution. Okay, so if we look at this first example here, we have 8x plus 8y equals 16, negative 4x minus 8y equals 16. So they're already lined up. We have our x's on top of each other, our y's, and our constants. This one, I noticed that we have positive 8y and negative 8y. So they have the same coefficients and opposite signs. So we don't have to multiply these equations by anything. So we're going to add them straight down. So we have 8x minus 4x gives us 4x. We have 8y minus 8y is 0. That goes away. And we're left with 16 plus 16 gives us 32. So now our new equation is just 4x equals 32. To solve that, we divide by 4. So we get that x equals 8. So this is the part that's new. And then next we need to plug this back in to get what x equals. So that's the same that we did in substitution. So you can plug it into either of your original equations. So I'm just going to choose the top one. So we have 8 times 8 plus 8y equals 16. So we have 64 plus 8y equals 16. We're going to subtract 64. So 8y equals negative 48 and divide by 8. So y is negative 6. So our solution that makes both of these equations true is 8, negative 6. For this next one, I notice that some of my coefficients are the same, but they do not have opposite signs. So if we just focus on the x's, these are also the same, the y's. But we have negative 6x and negative 6x. I want to make them opposite signs, so I'm going to multiply one of my equations, it doesn't matter which one, by negative 1. The whole thing, both sides, because that's going to flip all my signs. So I get negative 1 times negative 6x is positive 6x. Negative 1 times negative 4y is positive 4y. And negative 1 times negative 10 is positive 10. And then I just copy over my other equation. And now that we have 6x minus 6x, I can add straight down. So 6x minus 6x is 0. 4y minus 4y is 0. And then 10 minus 10 is 0. So this is one of our special cases where since we have 0 equals 0, that is a true statement. So we get infinite solutions. If you're adding this down and all your variables cancel out and you're left with like 0 equals 16, that's when it's no solution. So for this one, anytime you get infinite solutions, it will be 0 equals 0, and then no solution is 0 equals a number. Here's another example. So in this one, I notice none of my coefficients are the same, so I'm going to need to multiply at least one of my equations. So just looking at this, I notice that we have 7y and negative 14y. Well, 7 times 2 gives me 14, and they're opposite signs, so I think I'm going to multiply that top equation by 2. So 2 times 7x gives us 14x. 2 times 7y is 14y. And then 2 times 0 is 0. And I just copy over the bottom equation. So now that we have that 14 minus 14y right here, I can add straight down. So we have 14x plus negative 9x gives me positive 5x. 14y minus 14y goes away, it's 0. And then 0 plus 10 is 10. So whenever you're doing this, you should have one of your variables cancel out. If you don't, go back and check your work or multiply by something different. Divide by 5 to get your final answer, so we have x equals 2. And then to find out what y equals, we're going to plug this 2 back into one of our original equations. It does not matter which one. So we have 7 times 2 plus 7y equals 0. We're going to subtract 14 to the other side, so we get 7y equals negative 14. And divide by 2, so y is negative 2, or divide by 7. So our answer that makes both of these equations true is 2, negative 2. Now sometimes, like this last example, you're going to need to multiply both of your equations. So, looking at our coefficients, for x we have 8 and 7, and for y we have 3 and 7. You can't multiply any one of these equations just once to make it equal the other one. So, a good rule is to choose one of these and just flip it. So I'm going to multiply the top one by 7 and the bottom one by 3, because that will make them cancel out. And they're opposite signs. Sometimes there's smaller numbers you can multiply by, but this will always work. So we do 7 times negative 8x is negative 56x plus 21y equals negative 77. And our bottom one becomes 21x minus 21y equals negative 63. So we're going to add straight down. So my y's are going to cancel out. Negative 56 plus 21 is negative 35x. And then negative 77 minus 63 gives us negative 140. So my last step is to divide by the negative 35. So we get that x equals positive 4. And I'm going to plug that back into either equation. So I'm going to do 7 times 4 minus 7y equals negative 21. We have 28 minus 7y equals negative 21. Subtract 28. So we have negative 49 and divide by negative 7. So y equals 7. So our answer here is 4, 7. So sometimes, like in that first example, you don't need to multiply anything. You can just add straight down and a variable cancels. Sometimes you have to multiply one of the equations, even if it's just by negative 1. And sometimes you have to multiply both of them to make something cancel out. So this is our elimination method, and we are going to go over it more in class tomorrow. So come to class with any questions you have.